Hi, I'm Ron Fuller. I am a Senior Technical Product Manager with VMware. I focus on networking and security inside of VMware Cloud on AWS. And specifically today, we're going to talk about security both at the perimeter and inside the software-defined data center. So if we begin with looking at a typical SDDC topology, you'll see we've got a couple of different components that are always there. We have what we call our edge gateway, which is the border between the outside world and the inside of the SDDC. And then off of that, we have two separate routing components. One of them called the CGW, the compute gateway, which is where all of the segments that your workloads that you build inside of VMware Cloud and AWS will reside. They'll connect into that. And then we have the MGW. So let's start with the MGW, the management gateway. Its function is to provide networking and security for management components that you'll use and to configure the rest of this software-defined data center. Things like Virtual Center, things like NSX, all live behind the MGW. And because they're important components, we certainly want to protect them. And inside of the software-defined data center, we have two firewalls. We're going to focus on the first one, which is the gateway firewall, which is configured here on the default edge. And that is the gateway firewall, right? So the gateway firewall provides the ability to be able to configure kind of traditional access controls around who can get into and out of the environment. By default, the SDDC in essence is shut down. Nobody can get into the SDDC, nobody can get out of the SDDC until you, the security or network administrator, configures an appropriate policy to make that happen. That's an important consideration, right? You want to make sure that by default, security is in place and locked down from the very beginning. We do that with the policies that are configured on the gateway firewall. Specifically for the MGW, typically one of the first things customers want to access is Virtual Center, right? That's where you're going to configure your content libraries. That's where you're going to configure all of your workloads and virtual machines and things of that nature. So we start by configuring a policy on the MGW to allow external entities into the environment. Those external entities could come across the global internet. They could come across a direct connect or a VMware Transit Connect via the VTGW, or they could come internally across, say, a direct connect or things of that nature. So you would configure an appropriate security policy to allow access to Virtual Center, and then you get the look and feel of a traditional on-premises data center configuration, but you're in the cloud, you're in AWS. Additionally, the MGW is configured in such a way that it only allows us to be able to utilize groups that are based on IP addresses. So you're going to explicitly define the IPs of systems that can reach your management components, right? They're very important. So you want to make sure that this isn't just open to anybody that could potentially exploit your environment, but rather have it locked down so that it's just the folks who have the right access and the authority to be able to configure those components, the Virtual Center and NSX componentry as well. So that said, let's focus on the compute gateway, the CGW itself. When we talk about the CGW, we're going to define access for systems to get into and out of the segments that you, the network administrator, will create in this environment. These could be a single flat segment, or it could be a bunch of multiple segments to kind of mimic maybe an on-prem environment that you might have for, say, a traditional three-tier application. And so you can define that firewall policy in there as well. And it could be something as simple as any workloads can access any external interfaces, and we have a lot of customers who will do that. We have other customers that will be more kind of granular and focus their policy onto the specific subnets that things will need to access, whether those are internal amongst the CGW connected segments or to the outside world via internet, direct connect, or into the connected VPC. It's important to note that by default, the VMs cannot communicate with anything in the outside world, right? You have to define that policy as the administrator to allow them to be able to get access to to those external entities, and likewise for external entities to get in, right? So that's an important kind of consideration. So that's the gateway firewall, which is on by default. with everything pretty much locked down from the very beginning to provide a secure kind of foundation footprint. And then you as a security or network administrator will kind of poke those holes through the firewall to allow the appropriate access that meets your organization's requirements. So if we take our focus away from the gateway firewall and look at distributed firewall, this is a little bit different, right? The distributed firewall is something that we utilize inside of VMware, inside of any NSX environment, whether this is your on-premises environment or being able to carry that same firewall policy into the VMware Cloud and AWS perspective, being able to define firewall policy at a per guest level. And that's a very powerful capability, right? It starts to open up the opportunities for looking at security models like micro segmentation, and allows us to start to build towards a zero trust environment, right? So now I'm starting to build this environment where I'm reducing my attack surface on my workloads by implementing a firewall policy that's specific to that workload. And what the really cool thing about the distributed firewall, as its name kind of implies, it's distributed, which means that it's across all of the hosts. It's not a single kind of centralized appliance model like the way a traditional firewall would be. And the way we implement the DFW is we have a guest, right, a virtual machine that has a VNIC. That VNIC is connected virtually to a segment inside of on that connection, if you will, that virtual wire. We have the ability to be able to do firewall policy, right? So we can implement a firewall policy that inspects all the traffic that enters the VM or leaves the VM before it actually hits the virtual wire, if you will, right? So this gives us a very, very close relationship to the workload to be able to define a firewall policy that's appropriate for it. So if this case in the example was a firewall policy designed to get between a web server and maybe an application server running on, say, 443, we would be able to define a firewall policy that says that only port 80, TCP port 80, and or TCP port 443 are allowed to communicate amongst these workloads, right? So this gives us a very, very nailed down environment where I can be very granular in how I define my firewall policy so that I'm reducing the entire attack surface. The only thing that's open to that particular workload are the ports that are absolutely needed for things to work, right? So that's a very powerful kind of shift in mindset compared to a traditional source destination IP address configuration. Now it's really a matter of I define the ports that they can access, and I can start to use more abstract concepts like groups based on dynamic membership. So maybe I start to utilize tags on this workload. Let's say this workload has a tag of web. This workload has a tag of app. I can now start to define firewall policies that say anything with tag of web automatically has TCP port 80 enabled on it, or anything with a tag of app automatically has 443, right? So now I can start to be very generic in how I define my firewall policy, but also knowing that it's very specific in how it's enforced and what it's opening up across my environment. And it really frees us from the concept of being really married to the IP addresses, right? As I talk with customers, one of the common considerations the customers have is I need to be able to preserve my IP addressing because it's hard-coded into the application somewhere. It's in a batch file. It's in a host file hidden on machines. There's a whole bunch of Easter eggs out there, if you will, that customers have uncovered over the years with changing firewall policy. When we start to look at being able to kind of liberate ourselves from that mindset and go with the approach of no longer do I care what the IP address of the machine is if this machine's IP address changes, the firewall policy is still active and enforced, whereas traditionally it wouldn't have been, right? So this gives us a big mind shift change as well, and allows us to be able to do this micro-segmentation even on the same segments or between segments, right? So I can start to enforce firewall policy here as well between segments and within segments. So these are the two basic firewalls that are security mechanisms that are available inside of VMware Cloud on AWS out of the box, right? The distributed firewall is enabled by default, but the policy is permit IP any, if you will, for lack of a better kind of example. We don't want to break your network applications and flows. And then the gateway of firewall is enabled by default as well, but it's locked down, right? So you have to go through and configure this to be able to utilize these features. So these are the two kind of foundational capabilities from a security perspective that are available inside of VMware Cloud and AWS. And we'll build on this and talk about what we can do with the advanced firewall capabilities available in VMware Cloud and AWS in the next video. Thank you so much for taking the time. Have a great day.